Hello and welcome back to another episode of Ask an Expert. And tonight we're digging into the mysteries of the moon. We are joined by astronomer and co-founder of Blue Mountain Stargazing, Dr. Dimitri Duchen. Welcome, Dimitri. Thanks so much for joining us this evening.
Hello, Roxy. Thank you for having me.
Thank you. So tell us a little bit about yourself. Have you always loved space, and what led you to become an astronomer?
Yes. So when I was a child, I was told that I was always looking up into the stars, which I don't remember, I can believe. And then I decided at 8 years old I was going to be an astrophysicist. And so I worked my way up into all the studies that were required and did my master's degree in Paris. Decided to do a PhD in astronomy and astrophysics back in Sydney. And after that, I branched into a similar but different science, which is cultural astronomy. So looking into how different peoples and civilizations around the world look at the sky and trying to understand what it means about the sky, but even more so about who we are back on Earth as little humans. And in the meantime, my fiancée Caroline and I have been creating our business, Blue Mountain Stargazing, where we're inviting the public to look at the stars together with an astronomer in the Blue Mountains. And we've also just opened a new antenna in Jervis Bay as well, where we're able to see the sky with our laser constellation storytelling straight from the beach.
Oh, amazing. Well, I've been on one of your tours in the Blue Mountains and I can say it's amazing, so highly recommend.
Thank you so much.
So over the last week, we've had our audience submit questions to ask about the moon. Yes. And if you're watching at home, our social media handles will be popping up on the screen for you, so be sure to subscribe and follow to keep up to date with all our latest posts. So we'll dive straight into it. And the first question comes from Donna on TikTok. And Donna's asking, can we predict earthquakes or tsunamis based on the moon's phases?
That's a really good question. So depending on the moon phases, there's going to be some gravitational interplay between the Earth and the moon. So the moon will have a strong effect on the liquid on Earth, which is the tides and how the oceans are moving. However, the earthquakes are often created with collisions with tectonic plates. So basically how the mountains are being formed and the plates going under one another, it creates an earthquake. So the moon could have a gravitational influence, but it would be a minor influence. For the tsunamis are being formed when there's an underwater earthquake. So then there is a wave that comes out at the surface, the wave propagates, hits the beach where it keeps its whole height and then crashes on the beach. So this again is a phenomenon of tectonics more so than the Earth going around the Earth.
Right, okay, fascinating. So another one we've got in says, are there different types of eclipses?
Yes, okay. So eclipses, we know that the moon is involved in eclipses. How does that work? There's two types of eclipses. There's solar eclipses and lunar eclipses. So solar eclipses is when the moon is hiding the sun. They can be a full solar eclipse and then the sun is completely hidden, or a partial solar eclipse and the sun is partially hidden by the moon. There is this incredible fact that seen from Earth, the visible size of the moon and the visible size of the sun are exactly the same, where in fact in reality they're completely different. And so there's something completely incredible about that. It's completely by chance. So that's our solar eclipses. The lunar eclipses is when the shadow of the Earth is projected back onto the moon. So we've got the sun, we've got the Earth, and we've got the moon, and the shadow of the Earth is projected onto the moon. So here again we could have a full lunar eclipse or a partial lunar eclipse, which is called a penumbral lunar eclipse.
Yes.
So yesterday we had a penumbral lunar eclipse. That was beautiful at the moonrise. The favorite people who like the blood moons or the full eclipse moons is when there's that red color on the moon that appears. And that's because the light comes from the sun, passes through the Earth's atmosphere, and then you've got all the sunrises and the sunsets of the Earth that are projected onto the moon and that create this red color.
Beautiful. I didn't know
the
this.
Magic is, yes.
Very cool. Oh, amazing. So this is also an interesting one that's happened recently. Tori on Instagram would like to know, are worm moons a real thing and how do they work? Our first full moon in March in South Australia saw dozens of worms come up from the lawn and die on the sidewalk. It was bizarre. What is this? I've never heard of this before.
Me neither. I've never heard about worm moons. So there's two things. There is a behavior of animals guided by the moon to an extent. If you're fishing, certainly in Jervis Bay, there's a lot of fishing going on. You know that the moon creates tidal effects, and depending on the tide, you will get more fish or less fish. So there is a general effect of the moon on animals. I've never heard about the worms coming to the surface. So I can't speak for worm moons at all. However, there is something called a worm moon.
Yes.
Which is the name that we use, like one of these names that come back to fashion, like the wolf moon or the pink moon or any of those. And then people come to our tours and they expect the moon to be pink, and it's not pink, and they wonder why. So all these names, they're from the American Almanac, when farmers used to use the moon as a point of reference.
Okay.
And they refer to things in the environment that are happening. So the worm moon is in March in the US, is when the ice is starting to thaw and there's some little worms coming out the trees.
Oh.
I don't think it relates to the worms coming at the surface on the lawn. So maybe the gardener passed by yesterday and there's some herbicide projected onto the lawn.
Right.
Or there's a new phenomenon happening. But I've never heard of worm moons before, per se.
Okay. Well, interesting. Very bizarre, regardless.
Yes.
So someone from Instagram would like to know, how many moons are in the galaxy?
Yes. How many moons are in the galaxy? So let's count like an astrophysicist. We're not going to worry about the numbers. We're going to worry about the number of zeros.
Okay.
So in our galaxy, we've got about 100 billion stars, just like the sun. And each of these stars may have some planets around them. So in the solar system, we've got 8 planets plus the minor planets, the dwarf planets. So let's say there's 10 planets on average around each star. So that's going to be 100 billion times 10, and then we're going to say that each planet is going to have 10 moons. All right? It depends. If you look at Mercury, has no moons, Venus has no moons, the Earth has 1 moon, Mars has 2 tiny little moons, Jupiter has 93 moons, Saturn has 145 moons to the latest count, and some other moons as well for Uranus and Neptune. So the number varies. Let's make it 10. So we've got 100 billion times 10 times 10. That's the general statistical possible number of moons in our galaxy alone. And then multiply that by 100 million, and you've got 100 billion, sorry, and you've got the number of possible moons in the entire observable universe.
That's a big number.
It's a big number. So it's a 10 and 24 zeros after that.
Wow.
It goes on.
Okay, that's a lot of moons.
That's a lot of moons.
Okay, so Oscar would like to know from Facebook, what are the leading theories on how the moon was formed?
Yes. All right, so if you see the Earth and then you see a moon, you can wonder how this system came to be. So either the two formed at the same time, when the Earth formed, the moon formed next to it. That's a possibility. Or the moon got captured. It was flying in the universe and it got captured and started to rotate around the Earth. If you look at, again, Mercury, no moon, Venus, no moon, Mars, 2 tiny little moons. So it's very special that we have a moon here on Earth that is a quarter of the size of our planet. It's very, very big. So the most recent theory and the most accepted theory at the moment is that a hypothetical planet called Theia was about the size of Mars. And about 4.5 billion years ago, when the solar system was very young and things were flying around everywhere, Theia and the Earth collided into one another. And there was this big impact, and they both shed a lot of material. The Earth remained overall pretty intact, but Theia got pulverized and turned into dust, and the dust started to orbit the Earth. And over millions of years, the dust started to aggregate and rebuild the moon as we see it today.
Wow.
So there's lots of clues for that, but the biggest clue is that the moon is less dense than the Earth. So we believe that upon this collision, a lot of the lighter stuff flew away into the dust, and the heavier stuff stuck to the Earth. And so you can observe that the moon has a lot of a smaller core than the Earth, respectively. So that's one of the clues about the Theia hypothesis, or
Wow.
the big impact hypothesis.
I like that. It's cool. So Lewis from Facebook would like to know, is there any granite type of rocks on the moon anywhere?
Yeah, so there are small traces of granite on the moon. So granite is an igneous rock. So it's a rock that arises when there's an eruption. Here on Earth, we've got a lot of eruptions, so we're not surprised to see granite. There's small amounts of granite on the moon. So in the past history of the moon, there have been lava flows, and there have been some formation of granite. So there's small quantities, but we're not too sure what the small quantities arise because there hasn't been any recent eruption. The moon is tectonically dead. It's got no earthquake or moonquakes as far as it's concerned. So not much happening on the surface.
Okay, interesting. So we've got another question from Emmy on Instagram. She would like to know, what would happen if the moon just disappeared? Would it severely impact our oceans, and could humans survive?
All right, so this is a tough one.
Yeah.
And people ask me that a lot. If a sudden a moon appeared or the moon disappeared, what would happen? So it depends if it were to disappear gradually or if it were to disappear all of a sudden. But the moon is regulating our tides, and the tides is a huge engine to our ecosystem. So a huge disruption without the moon, our ecosystem would be very impacted. The moon is, after that collision of Theia and the moon started wobbling in completely random direction for a long time until the moon stabilized the Earth as it's orbiting around it. So without the moon as well, we wouldn't have been that stabilization of the orbit. But finally, the moon is disappearing a little bit away from us. It's moving away from the Earth at a rate of 4 centimeters per year. So that's not huge, but combined over millions of years, the moon is going to reach a point where it's not exchanging momentum with the Earth's rotation energy with the Earth, and the moon will be stuck and locked looking at the Earth all the time. So in some countries, you'll have the moon in the sky all the time, and in some countries, you'll have never the moon. But that's in a few million years. We have time to prepare.
We have time to prepare.
That's right.
So someone from Instagram would like to know, does the fullness of the moon determine its effect on Earth?
Yes. So yes and no. So the fullness of the moon has to do with its appearance. So the phases of the moon, when the moon's completely lit up, it is full. So it is not the fact that we're receiving a lot of light from the moon that is impacting us, but it is that when the moon is in that position around the Earth, that's when it's aligned with the sun, and that's when the tides are the strongest. So in that regard, yes, there is.
Okay. And why does the moon seem bigger the closer it is to the horizon?
Yes.
Yeah.
So yesterday, we were in Jervis Bay on the jetty looking at the eclipse rising and the moon rising. If you've never seen the moon rise, it's one of the most understated spectacles. It's spectacular. The moon comes above the horizon. It looks really red, just as the sun goes down and becomes red. The moon is very red as well when it sets and when it rises. And so there's two possible reasons. The first one is a physical reason called refraction. If you ever put a straw into a glass, you may have noticed that the straw looks bent. The same is happening with the rays of light that are passing through the atmosphere. But the rays of light that are passing from the top of the moon to the bottom of the moon do not follow the same path. So they're refracted differently, and it could be an effect of deformation that makes the moon appear bigger.
Right.
The second effect is cognitive. As humans, as we see the moon, suddenly we have a point of reference, and we can compare its size to objects on the horizon.
Yeah.
And so it looks enormous compared to like the trees or whatever you'd see on the horizon. If you ever look at also like constellations like Orion, when it's setting, it will also look enormous. It's taking a huge fraction of the sky, but suddenly you've got a point of reference that you can put it into in comparison. And that's why for us humans it looks so poignant.
It's very awe-inspiring when you see that moon rise, and it's
beautiful.
Huge and beautiful. And
yes, very romantic as well.
Yes, definitely. Okay, so someone from Instagram would like to know, do people actually go crazy during full moons? And if so, why?
Yes. So there's a lot of people who report that. So what's the reason behind that? If we decompose the experience of a full moon, there's two things that could be happening. I think the first thing that is the most impactful is the light from the full moon. Full moon is really bright, and you can walk outside on the light of a full moon as if it were a bright day. Like it's really, really bright. So if people live in places where light is leaking into their living space, they will be pretty disturbed by that light. The other effect is then that there could be an influence with the gravitational pull of the moon, right? We talked about the worms coming out the lawn, if that's a thing, but also the fish and all sorts of behaviors that are affected by the moon. If the moon's affecting the tides, why would it not be affecting the water in our cells, for example, and impact the behavior in our cells? So on nights of full moons, if you work at the EI, you'll hear that a lot of people, the service is a lot busier at that time. There's also, unfortunately, more suicides at this time. So it seems to be impacting us humans, who are just another animal in the ecosystem, I guess.
Yeah, very true. I have a friend who's a nurse, and she always says full moons are very busy,
So
very busy nights.
Yes.
Yeah. Yeah, very interesting. So could Earth theoretically gain another moon?
Oh, there we go. So that's we removed the moon and we're
now we're adding a moon.
Yes. Theoretically. So it could with the same mechanisms that I mentioned earlier. So if there was something flying around the solar system, typically from another galaxy, an interstellar moon, that would be, or interstellar moon from another star into the solar system, the Earth could capture it if it was the perfect trajectory. Sure, why not? If there was a stream of material that was coming towards the Earth and the gravitational field of the Earth could capture it, yes, why not? These are the only two possible scenarios. If another planet collided with the Earth and there was another Theia collision, and then we'd have two moons and the Earth, why not? But all these scenarios are very unusual because the solar system now has been formed for 4.5 billion years. So everything is on a pretty stable orbit. So other than something coming out from another star, there's not much that's going to be too disruptive, other than maybe a comet or a meteor within our solar system.
Okay, so it's not very likely.
It's very unlikely.
Okay. Now, how far out of Sydney/cities do you need to go to really see the stars?
Yes. So it's all about the really. In the city, you'll see only really 3 or 4 stars, the brightest stars. So the quality of the sky is established by a criterion called the Bortle scale, B-O-R-T-L-E. So a Bortle 1 is really, really good. So if you go to Uluru or the Red Centre of Australia, you have a 1. In Jervis Bay, we've got a 2 or a 3. In the mountains, the Blue Mountains, we've got a 3 or a 4, all the way to 9, which is like Sydney, Melbourne. Big city level, which is where you can't see anything. So the further away you drive, the better you'll be. But if you only drive 1 hour away from any big city, you'll start to be able to see more stars. My criterion for a good sky is if you can see the Milky Way and if you can see the black patches in the Milky Way. So the Milky Way will look like a white drag across the sky, and you'll see some little figures in it, little black patches.
That means it's a good clear sky.
Then you have good detail on the Milky Way, you've got a good sky.
Great. And just for those at home, if you do want to do stargazing, we have an incredible selection of telescopes available on our ausgeo e-store, so definitely be sure to check those out. So the next question comes from Charlie on Instagram. It says, what would it take for a person to realistically survive a lifetime on the moon?
Okay, so this wouldn't be any different to surviving in space. For a lifetime, or even in desert to an extent. So you'll need your water, you need your air, you need your food, you need your temperature regulations, pretty intense variations on the surface of the moon. So these are just the physiological ones. Breathing temperature, yes. Gravity is nice because if you spend too long in space, there's effects that is happening on bones and things like that. So on the moon, the gravity is a lot less, so there could be some impact there. And then maybe a few friends would be nice as well. Because if you're a lifetime on your own on the moon, that's like serious hermitage there. That's
a few friends, some gravity would be nice.
Yeah, and the gravity could be a good beginning.
Okay, good few criterias there. Ben from Facebook would like to know, what is and why do we have a dark side of the moon?
So undeniably, Dark Side of the Moon is a really good Pink Floyd album.
Yeah.
But it's not a thing on the moon. Okay?
Yeah.
So there's no dark side of the moon. There is a near side of the moon and there is a far side of the moon. So the moon is always showing the same face to us. You may have heard about the rabbit on the moon, the black patches, or the face on the moon, the man on the moon. So the moon is always facing the same side to us. So there's a side that we can never see.
Okay.
So the side that we can see is called the near side of the moon, and the side that we can't see is called the far side of the moon. But all the sides of the moon, as the moon is spinning around the Earth, are being lit up by the sun. So there is no dark side of the moon. There's only a near side and a far side, as seen from Earth. Yes, and really good rock and roll music.
And really good rock and roll music.
That's right.
Okay, great.
To bring in your spaceship.
Okay. So Lucy from Instagram is asking, why does the moon have so many craters, and is its surface still changing?
Yes. So typically when you use one of those telescopes, and one of the first things you're going to look at is the moon, and you'll see those craters that are looking beautiful. So craters come from impacts of meteorites or meteors that have crashed on the surface, so rock pebbles that have crashed on the surface and left a mark. Most of the craters that we see on the surface of the moon come from an episode that was 4 billion years ago. That's called the late heavy bombardment, which is when the solar system was still forming but starting to get settled. A lot of things were flying around and started crashing on the moon. So that's how the craters formed. On Earth, we don't have that because we have an atmosphere that is protecting us like a blanket of gas. So all the meteors coming through burn in the atmosphere, turn into shooting stars, which is where shooting stars come from. On the moon, there's no atmosphere, so everything that's going there is going to crash on the surface. So most of the craters come from that time. The surface is still changing, and there's still meteors crashing on the moon. I think one of the latest ones was in 2013, where they observed the crash on the surface from a telescope someone had taken a movie. So they retraced the coordinates, couldn't find the crater, but they saw some lines coming through some spokes, and they followed that, the point of convergence, and discovered the new crater that was formed. So there's always stuff happening on the surface.
Yeah.
It's an evolving.
Always new things crashing into it.
That's right.
So what are people currently studying on the moon? Like, is there anything there?
Yes.
Yeah.
Yeah, so there's many interests about the moon. It could be about how did the moon appear in that Theia collision and testing that hypothesis any further. It could be about measuring the geology and how space weathering is the hard radiation from the sun is impacting the ground, all this stuff, because the moon has no atmosphere. So it's interesting to see its evolution. But at the moment, the focus on the study is how to live on the moon. And how can we turn the moon regolith, the dust, the surface of the moon, into oxygen, for example. It would be nice if we could breathe. There's a lot of interest about going to Mars, and the first step defined by NASA is, and a reasonable one, is to stop on the moon.
Yeah.
So we've had the Artemis missions, Artemis 1 and 2, that have launched successfully in the past years. And in 2025, we're going to have Artemis 3 that are going to be seeing the new generation of astronauts walk on the moon again. And so that's next year. I've been saying this so many times, but now it's just next year. And that's going to be also the first female astronaut on the moon and the first man of color on the moon. So big step for aerospace and big step for social justice as well.
Yeah. Oh, very excited for that. That'll be very exciting. So are there actually tardigrades on the moon? Could they survive, and would they come back to life, so to speak, if water were to reach the moon?
Yes, so tardigrades are so fascinating. So tardigrades, if you've never heard about them, they're little sub-millimeter animals. They're called water bears. They look a bit like big fluffy bears. And they can survive extreme conditions, even more extreme than the conditions on the moon. So the moon for them are a pretty comfortable place to live. And the way they can survive in hibernation in extreme conditions is just by removing all the water in their cells and replacing it with sugar. And then they roll up in a bowl, and then that's lights off until water comes back again. So they've got this incredible ability. Now, they can survive like that in space. There's been tests in the International Space Station of taking tardigrades out in space, and they can survive. So they could survive on the moon. But then you'd have to place tardigrades on the moon, right?
Yeah.
So has this been done? Well, it has happened, actually. So there is a probe that was sent to the moon that crashed that contained tardigrades in it. So that's the fourth species that was sent to the moon, together with, I forgot the first one. Then we had the flies. Then we've got the worms, and now the tardigrades. So the tardigrades could actually survive, and they can survive in hibernation for about 10 years.
Wow.
So it'll be good to see when those people from the Artemis mission go and inspect. They won't inspect the crash, but another crew to see if those tardigrades are still alive.
Wow, that'll be really interesting to see if they are.
Yes, it would be the first extraterrestrial life to
and
survive.
they look kind of like aliens as well.
They very much look like aliens.
Yeah, they fit the bill. So
that's right.
Maybe
they're
they're
all
the right.
features.
Yeah, the right ones to send up there.
That's right.
So Can you explain moon phases and how they work? Why does the moon look different at different times of each month?
Yes, if only I had a moon with me. Oh, look at this. It's just the moon right there.
One you prepared
How
earlier.
convenient. Here's one I prepared earlier. So we've got a moon right here. So the phases of the moon, a lot of people assume are the projection of the Earth's shadow onto the moon. But as we mentioned earlier, that's when an eclipse happens, but it's not how the phases work. So the phases work is just about the angle at which we're seeing the moon turn. So let's say if I am the sun and I'm lighting up the moon, this whole part of the moon here is going to be lit up. And so that's going to be a full moon. Now, if I'm on the other side of the Earth, right here, and the sun is in that direction, we won't be able to see any part of the moon. That's the new moon. And then if the moon is a little bit in between, then it'll get only half a fraction of the surface. So we'll see half of the moon being dark and half of the moon being bright, which is the first crescent or the third crescent. So it's just literally if you put a ball and a torch and you play with turning the ball around the torch, you will see the phases of the moon appear. It's a game of light from the sun. It's not a game of light from the shadow of the Earth. And so why is it a different phase? Why don't we have a full moon every third of the new month? Is because the moon cycle is about 28 days for the moon to go around the Earth, but a month is typically 30 days or 31 days, which as it turns out is pretty random as a measure, and it's not following the cycles of the moon at all anymore as a calendar, which is fascinating. So that's why you'll see a different moon at different day every month.
Okay, well that explains a lot. So that actually concludes our show for this evening.
Already? That was so much fun. We just started. Yes. All right.
Well, thank you so much, Dimitri, for coming on the show. It's been an absolute pleasure.
Thank you, Roxy. It's been awesome.
And for you at home, remember to support the Easter Bilby this year, not the Easter Bunny. So you can do this by purchasing the new issue of the Ausgeo Journal, or by purchasing one of our removable Bilby tattoos for just $2 from any QBD store, and all profits will be going to the Australian Wildlife Conservancy. Thanks so much again, and we'll see you next time.